मैंने अपने बेटे को अभी बुलाया था, तो वो जो है ना, ही इज डूइंग पीएचडी फ्रॉम हियर। तो
Okay.
वी आर लिविंग टुगेदर बिकॉज माय डॉटर गॉट मैरिड ना, तो उसके बाद में हम लोग यहाँ आ गए।
Yes,
तो
sir.
आई एम
Yes,
इन
sir.
यूनिवर्सिटी ऑफ वाटरलू। सो अभी मैं यहाँ एडजंक्ट प्रोफेसर ज्वाइन करने जा रहा हूँ।
Okay.
तो देन एक्चुअली आई एम वर्किंग ऑन स्ट्रॉबेरी क्रॉप एंड टोमेटो क्रॉप मॉडलिंग। तो इनका
Okay.
ग्रुप है, मशीन लर्निंग के ऊपर मैंने काम शुरू किया है। मशीन लर्निंग और एआई एंड क्रॉप मॉडलिंग लिंक कर रहा हूँ।
Exactly, sir. This is one of the advanced fields, sir, machine learning
हाँ
and AI.
हाँ। तो ये बेटा जो है ये इसमें बहुत ट्रेंड है। इसको अभी गवर्नर जनरल गोल्ड मेडल अवार्ड भी मिला। तो
Okay.
ही इज वर्किंग ऑन बिग डाटा बेसिस। तो
Okay.
और आप ठीक है बिल्कुल, सिराज एंड लतीफ?
Yes, sir. Yes, sir. Yes, sir. दोनों ठीक है, sir. दोनों ठीक है.
अच्छा, चलो कभी कभी आ जाओ है आप यहाँ अपना। अब तो एंट्री बड़ी आसान हुई हुई है, कनाडा में आप
जी
आ
जी
सकते हो।
जी सर, जी
क्योंकि
सर,
कोरोना के कारण क्या है कि लोगों को एक एक महीने में पीआरशिप मिल रही है,
जी.
ग्रीन कार्ड मिल रहे हैं यहाँ आने के लिए।
Sir,
तो
convey our congratulations to your son, sir,
हाँ,
for getting an award,
यस यस
sir.
एक्चुअली।
Organizing committee की तरफ से sir हम उनको congratulate करना चाहते हैं sir
थैंक यू थैंक
for
यू थैंक
having
यू।
this wonderful award, sir.
इज दैट वे लाइक नाइस लाइक यू। आप भी लोग काफी एक्टिव हैं। आई एम वेरी हैप्पी कि भाई आप लोगों ने तो किताब भी छापी दोनों ने Then,
जी
और
जी जी जी.
लतीफ को तो मैं देखता रहता हूँ, इज वेरी एक्टिव ऑन रिसर्च गेट। तो
Yes sir,
क्वेश्चन
yes sir, yes
आंसर्स
sir.
में काफी लगे रहते हैं, और जो है एंड ही
बहुत ही एक्टिव है सर, बहुत ही एक्टिव है.
इज वेरी एक्टिव इन दैट एक्चुअली।
सोता नहीं है ना सर, ये सोता नहीं है.
अच्छा, वो बेटे की तरह, बेटा भी 3 घंटे, बेटा 3 घंटे सोता है हमारा सिर्फ। वो अभी तो भी मैं उठा
लतीफ
दिया।
doesn't लतीफ doesn't sleep.
Oh my God, अच्छा
मैं तो 2-3 घंटे मारता हूँ.
अच्छा अच्छा। तो लतीफ, गुड, कीप इट अप है। और एक और
but
किताब लिख
but nice
डालो है इसका, जो इंटरनेशनल सेमिनार कराया इसमें किताब लिख दो दोनों मिलके।
सर एआई पे लिख
जी
डाली
जी
सर,
जी.
एआई मशीन लर्निंग पे एक बुक आ रही है सर टेलर फ्रांसिस की।
हाँ बहुत अच्छा है, दैट्स वेरी गुड। एक्सट्रीम क्लाइमेट के ऊपर एल्सेवियर में भी मुझे एक आया हुआ था कि आप एक्सट्रीम क्लाइमेट्स पे, क्योंकि बांग्लादेश में मैंने ना वो एक्सट्रीम क्लाइमेट्स में काफी काम करवाया था। तो देन
जी
एक्चुअली आई थॉट कि जो मैंने आज टॉपिक लिया ना, उसके अंदर मैंने काफी डाइवर्सिफाई करने के लिए उसको स्लाइड को चेंज किया, बट आई विल टॉक ऑन एक्सट्रीम्स आल्सो। बट देन एक्चुअली उसमें एल्सेवियर में, जैसे अब बांग्लादेश के एक्सट्रीम क्लाइमेट्स बहुत हैं, और आपके जैसे कनेडियन सिस्टम में बहुत ज्यादा है, आपके जम्मू कश्मीर में भी आता है कि कोल्ड क्लाइमेट्स में क्या मतलब हाउ टू सस्टेन एंड ऑल दैट, बट स्टिल एक्चुअली द काइंड ऑफ द वेरिएबिलिटी इज वेरी हाई। एक्सट्रीम्स बहुत ज्यादा आने शुरू हो गए हैं, तो ये सारी बातें बड़ी इंपॉर्टेंट हो रही हैं। तो इसलिए मतलब जो है ना, कुछ मॉडल्स भी हमने इसमें बनाए हैं, कुछ तो ऑलरेडी एग्जिस्टिंग मॉडल है। आर क्लाइम डेक्स तो आपने चलाया होगा।
जी जी सर।
आर क्लाइम डेक्स के ऊपर हमने पब्लिश भी किए 1-2 पेपर। तो ये पार्टिसिपेंट्स हैं, इनको कह सकते हो कि दे कैन जस्ट सी ऑन रिसर्च गेट माय पब्लिकेशंस, जो के साथ पिछले 2-3 साल में हम लोगों ने छापा है। तो 25-30 पेपर इकट्ठे आए हैं।
जी जी
तो दे कैन रेफर टू एक्सट्रीम क्लाइमेट्स एंड क्लाइमेट चेंज, और जो मॉडलिंग के आउटपुट्स हैं। और एक हमने अभी मूंगबीन मॉडल भी बनाया उसमें, और कुछ मैंने फॉरेस्ट्री में काम शुरू किया। तो पाइनस रॉक्सबर्गी को का मॉडल का ना, अभी मैंने एक पीएचडी स्टूडेंट ने, आपको याद होगा मनोज कुमार एक आए थे हरियाणा
हाँ
में।
मनोज सर, हाँ
हम्म.
यहाँ देहरादून से आए थे।
हाँ, तो मनोज ने मेरे साथ ही किया था फिर।
ओके।
तो अभी 2018-19 में उसका पीएचडी हुआ। तो ही इज नाउ सीनियर साइंटिस्ट देयर। तो उसका पाइनस रॉक्सबर्गी के ऊपर मॉडल का उसका बना है। तो बहुत अच्छा है उसका भी।
तो हमारे यहाँ पे 3 निश क्रॉप्स है, हमारा ये सैफरॉन है, काला जीरा है और एप्पल है। तो हम सोच रहे हैं कि इस पे मॉडल बनाएं।
ओ यस यस।
और आपकी हेल्प चाहिए उसके बगैर।
नहीं
शिराज
नहीं
में
नहीं,
मेरे
जरूर
2-4 प्रोजेक्ट्स है सर।
जरूर जरूर जरूर, हम आपके साथ हैं। आपका कॉन्टेक्ट दोनों का हमारे पास है। राज का भी व्हाट्सएप कॉन्टेक्ट नहीं मिल रहा, पहले तो था, अब नहीं है, हैं?
नहीं सर, मैं ज्वाइन करूंगा सर आपको जल्दी अभी.
मैं चेंज होगा सर अब।
आज
लतीफ
आज से
लतीफ का
मैं.
तो आज मिल गया।
हाँ
लतीफ का
हाँ
आज
हाँ,
सुबह सुबह ये ड्राइव कर रहे थे तो मिल गया इनका।
बिल्कुल. नहीं नहीं, पहले कह रहे थे व्हाट्सएप. मैंने कहा सर का व्हाट्सएप नहीं है, हमारा ईमेल के जरिए कांटेक्ट है.
अच्छा
Uh,
अच्छा अच्छा।
then he is connected, sir. Sir,
तो
well, I think our participants has maximum participants has joined, sir.
ओ यस यस यस,
Uh,
नाइस। I'll be happy और I always welcome कि आप दोनों हमारे साथ जुड़े रहें और किसी स्टूडेंट को कोई मदद चाहिए तो हम बैठे हुए हैं यहाँ कोई
आपको हम नहीं
इंटरनेशनल
छोड़ेंगे सर, आपको
और
छोड़ेंगे ही
कोई
नहीं कभी।
यस 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 और गुड मॉर्निंग
Sir, let us start. I
यस
welcome and a very good evening to all the participants. And good morning to Professor. Blessed to have with us in this evening session, Professor Naveen Kalra, who has been. I would firstly request Dr. Latif to formally invite you and introduce our respected speaker to all the participants. Professor Latif, please.
Okay. Good morning, sir, and good evening to all the participants. We are blessed to have Dr. Professor Naveen Kadra with us. He is the modeling guru in our country. So, sir did his BSc honors in physics from Delhi University, then MSc physics from Delhi University, then PhD from IIR in New Delhi. He is doctorate in soil physics, soil and water conservation. Then the experience sir is having climate change and variability assessment, climate change impact on agriculture, forestry, natural resource management, vulnerability assessment, mitigation and adaptation strategies, sustainable production, environmental impact assessment, soil water pollution, on-farm water management, simulation modeling, remote sensing and GIS, soil and water conservation, machine learning application, agriculture. Sir is having vast experience of 41 years in research and teaching. Sir has worked as technician at University of Ontario Institute of Technology, Oshawa, Toronto, July 18 till April 2019 on contract employment for machine learning application agriculture. Sir is also a course instructor in limited appointment winter semester January 19 to 19, April 19 to teach undergraduate course on climate change at Trent School of Environment at Trent University, Peterborough, Ontario, Canada. Earlier from 2012 to 2018, Sir was with Bangladesh and at Forest Research Institute and acted as a trainer consultant for program of impact of climate change on Bangladesh agriculture and at Forest Research Institute, Dehradun, Uttarakhand, India for climate change, climatic variability and forest growth mitigation adaptation strategies, vulnerability assessment using agriculture and forest growth modeling. The past experience Sir was earlier professor and head and principal scientist division of agriculture physics, IIR. Then as Sir was in Tata Chemicals also as director, and Sir is having around 300 publications in credit, 11 books and 34 technical reports. Sir has handled so many projects like the projects on crop modeling, agrometeorology, remote sensing, GIS, climate change impact, environmental impact assessment, water and nutrient management, generated national and international fundings for the associate institutes. Sir has also have been awarded Hooker Award IRA for 2002-2003, Fellow of Royal Meteorological Society of UK in 1993, Jawaharlal Nehru Award in 1987, Dhiru Morariji Memorial Award FAI in 1995, and Sri Ram Fertilizers Award FAI in 2007. So on behalf of participants and the organizing committee, I welcome Professor Naveen Kalra, our mentor, our guru. We are very delighted and happy to hear you. Please, sir.
Thank you, Professor Latif, for meeting you and seeing you after a long time. We were together in 2013.
Yes.
And I keep on seeing your work on ResearchGate. You are very active, and Shiraj also. And then I see that they are doing really nice work, and I'm happy. And at present, actually, I'm in Toronto at Waterloo, University of Waterloo. So, and then actually I'm staying here. I may be joining here with the faculty of at University of Waterloo. So I may be being as adjunct professor, and as well as actually at present I am working on strawberry crop modeling, as well as we are starting tomato crop modeling group also. That is with California environment, where the fruit and vegetable productions, it's a hub of fruit and vegetable production, and the productivity also is very, very high. So that way, actually, I'm just trying to request Latif also that we can do some work actually,
yes, surely,
from Jammu and Kashmir environment in a way that we can link up some crops, important crops like you, in a way to develop those models. And I'm always there with you in a way
Thank you.
to help you to the extent that the student and the younger scientists also can join. So that way, actually, I'm happy that they should come with us, and then actually we should try to form that group, and can take the shape of international mission from this side, North American side, in a way that we can do that. So now actually I'll start my presentation
Please, sir.
in a way, but today I'll be talking very diverse in a way to raise some of the issues related to agriculture research, and that way actually some of the advanced research can be initiated. So that's why I thought that I'll be in between also touching some aspects. So can I start my presentation, Latif?
Yes, sir. Yes, sir.
Please, you start your
Okay.
presentation, sir. Please.
Okay. So I'm talking of using simulation models for climate change and natural resource management for sustainable agriculture. So actually, you see the concerns are agriculture concerns are too many. It is declining and deterioration of natural resources, soil degradation, nutrient mining, and multiple nutrient deficiencies, decrease in soil organic carbon, overexploitation of surface and groundwater resources, environmental issues like climatic variability change, extreme events, solid waste and effluents, pest buildup, decreasing biodiversity, shrinking farm profitability, declining factor productivity, nutritional insecurity. So actually, I worked with Bangladesh group. 50 scientists were there, and then actually I see that the organic carbon content of Bangladesh is relatively higher than Indian average organic carbon. So organic carbon is of the range of around 1% in Bangladesh average. Somewhere we have around 2% or more than 2%. Whereas actually in India, if I talk of Punjab, Haryana, it is around zero point 0.3 to zero point 0.4, very low. Although we are getting higher production in Punjab, Haryana, because of the climate, because during flowering of wheat crop, the climate, this temperature gets reduced, as well as they are giving more inputs in terms of water and fertilizer, so they are getting more yields. Otherwise, actually, the Punjab soil, if I say, is relatively poor in a way from productivity point of view, unless we are applying those water and fertilizers to a greater extent, which may be causing some kind of, like say, decline in water table. About 80% of the water table districts in India, the water table is declining at the rate of around 40 to 50 centimeter per year. So that way actually you see that it's a greater concern. If I see that the nutrients, the zinc deficiency is spotting up at some places, the NPK's deficiencies are also coming. So we have to design those kind of integrated nutrient management programs. I was at Tata Chemicals, where actually I developed a lot of fertilizer products and tried to understand about the kind of the multi-nutrient interaction. I devised those particles having all the kind of the nutrient needs of a particular crop or a particular production level. If I want to increase the production of a particular area by 25%, how much fertilizer should be added, how much micronutrient should be added in a way. So all those kind of models I developed at Tata Chemicals, and then we designed customized fertilizer. So that way actually side by side the climate change also is there. So you see that when I talk of the climate change is noticeable. But then extreme climates, the probability of occurrence of the extreme climates have increased. So that way actually it's a greater concern. Somewhere near flowering of wheat crop, if I say the temperature rises, the duration of the crop, the grain filling duration reduce. That way the productivity gets reduced. So that way actually you see that a lot of concerns are there. If I compare Bangladesh environments, there also the extreme climates are there, where actually we have to understand the linkages of the management, agronomic and resource management options in a way to meet those challenges of extremities. In a way, we have to understand. We have to characterize the extreme climate occurrence and the extent of extreme climate which has come. and for particular growing regions, we have to evaluate. So that way, actually, you see that basically, and that there are certain models, like say, I was talking with Dr. Latif, that our Climadex, one model is there, where we try to characterize the extreme climates in a particular growing region. Like say, if I one paper I have published for entire Bangladesh, the extreme climates and the effects on rice and wheat productivity. So that way, actually, you can please see the on ResearchGate. I have put all those research papers. So climate change, extreme climate, climatic variability, and the simulation results of crops like rice, maize, and wheat. So all those kind of results we have done for Bangladesh. So in last 3 years, actually, my activity has been with mostly with the Bangladesh group, and then with the Forest Research Institute, Dehradun, where we worked on Pinus Roxburghi also. In a way, we developed a crop model, a forest growth model for Pinus, and then actually it did not take much time for us. So maybe I took around 2 to 3 months time to develop this model. So I was telling Shiraj and Latif that you can take up some new crops, ventures, as well as some of the tree types, tree species, in a way that you can cover those things also, and then you can raise those newer platforms for climate change kind of things. So, and then always the young scientists and the students are welcome in a way to join those missions with Latif and with Shiraj, and then they can always join with us. So now, actually, NRM and related components in relation to climate change. When I talk of the climate change, climatic variability, I talk of the soil resources. I'm talking of soil water availability. Soil fertility is very important. Although actually there are numerous experiments on fertilizer trials and all that, but the micronutrient interaction is very poor understanding in a way that how we have to management in relation to crops. Then actually, when I talk of the soil water availability and soil fertility are very important. And then actually, when I talk of the soil reaction, that's important for countries like Bangladesh, where the pH is relatively acidic. Somewhere we have a in Sundarban deltas kind of thing, we have saline sodic patches also. So that way, actually, we need to understand that how these particular soil reaction in a way is responding to the productivity, and what are the kind of the management options, and how these buildups are taking place with time. It's not only question of climate change and climatic variability. It's the
Excuse me, sir. Hello.
yes. Hello.
Sorry for interruption, sir. Sir, your voice
Yes.
is not audible, sir.
It's not coming.
No, voice
Sir,
is coming, sir.
you first mute, then again unmute, sir. Sir, now unmute, sir. Left. Sir, you have to unmute the mic.
Kindly unmute, sir. Now it was coming, but
Sir,
still
go to
low.
PPT, sir. Go to PPT, sir.
Now it is unmute.
Yes, unmute is. It's unmute now.
Now again I have to open that one, that PowerPoint.
Sir, go to Zoom. Zoom.
Okay.
Now I'm audible.
Yes, sir.
Okay.
आवाज थोड़ी कम आ रही है, पहले से ठीक आवाज आ रही है।
आ रही है?
आवाज आ रही है सर, आवाज आ रही है, लेकिन कम
आवाज आ रही है पर कम आ रही है sir, but maybe because of the network issue, I think. You carry on, sir.
But I'll be a bit slow, because then actually the participant should able to hear me.
It has come now. It has come now,
Yeah, now
sir.
it is okay, sir.
Okay.
It is okay, sir.
Okay.
Thank you, sir.
Thank you.
Proceed.
Thank you. Latif and Chirag.
Yes.
So, and then actually the water resources climate change, when I talk of, the water resources are very, very important. Surface and groundwater availability. Quality aspect is very important. It's not only climate change, it's also the rapid land use and land cover change because of the industrial pressure, because of the intensive agriculture activities happening. In India, actually, we see that the intensive agriculture enhancement is taking place, but we cannot afford it because the soil organic carbon content is very low, fertility is low. So that way, actually, you see that we have to manage those systems in a way that how we can sustain the production. Then actually you see that the atmosphere greenhouse gas emission, aerosols, UVB and ozone regards, and then actually the vegetation, forest and annual perennial crops, where we are talking of the phenology, net primary productivity and plant processes. So these are the kind of the things which comes in relation to climate change and climatic variability, linking these aspects also. So because I am a system scientist, so I try to integrate all these components together through models. Like say infocrop model we developed at IRI, PK Agrawal, myself, we developed that model for 16, 17 crops. Then we worked for some other crops in Sri Lanka also I worked for tea and coconut. And then actually you see that some of the crops like now I am adding in North American environment, where actually I am adding strawberry crop also. So that way actually some of the newer additions are taking place. So see some of the concerns are the with the intensive agriculture, the multi-nutrient deficiencies are emerging. Like say boron is there during 1990s, the boron deficiency was reported, and then 2000 also some of the other deficiencies are also coming. So that way you see that with time, because of the intensive agriculture systems, we are exploiting the soil. In that process, the multi-nutrient deficiencies are reported. But some states like Haryana, Punjab, they are giving more dosing of zinc and then boron. So that way the utilization of, you are able to hear me?
Yes, sir. Yes, sir.
Then actually you see that basically actually you see that sometimes in micronutrients we are over applying them. So you see that we need to understand about potassium is antagonizes. If I apply more potassium, calcium, magnesium will antagonize. If I apply more iron, manganese will interact. If I apply zinc, phosphorus will then start antagonizing. So that way actually a lot of antagonism is there. So we have to use the balanced fertilization in relation to the changes whatever are taking place. Then actually you see that the declining in organic carbon content. If I see the long-term fertility trials, in Pantnagar, you see in 70s, the organic carbon was very high. But then if I observe the unfertilized area in rice and wheat crop, so there actually you see that the organic carbon is declining and becoming static at around zero 0.6. In Punjab, already you see the organic carbon was around 0.3. And in unfertilized soil, also it's almost constant. So you see that it almost has come to the minimum limit. It cannot go further down. In Palampur, you see the organic carbon is almost showing a static sign around zero 0.7 or so. So this is because of the forest and agriculture interactions happening. In unfertilized also, it's showing a kind of a stabilize. So that way actually we need to understand how the organic carbon, in climate change we talk of the carbon sequestration, how we can sequester or fix the carbon in the soil in a way that carbon dioxide emission can be reduced, GHG emissions can be reduced, as well as the organic carbon of the soil can be maintained in a way to have the higher productions. So that way actually these kind of different scenarios are there. In Bangladesh also, I noticed that kind of trials, similar results are happening, but they are talking at their fertilizer dosing is low in comparison to what their productivity is relatively very high. Rice productivity is almost 2 times the productivity of rice, which we average productivity of rice we get in India. You see that way actually the Bangladesh that way is a high productivity platform or region compared to India because of their higher carbon contents. So I'm trying to just raise those issues in a way that what are the kind of the concerns. If I talk of climate change, I need to address about the water, I need to address about fertilizers, or I need to address about the soil microbial activities and all that in a way to understand that how climate change will look like, in a way to have effects on these systems, in a way to have sustainable agriculture production. So simulation developed by our center at IRA was WT Grows, which we developed in '94. We published in Field Crops, and it took around 5 or 6 years for us to develop this model. My PhD was also that time when I developed the WT Grows, and then actually ERI platform was there with Philippines group. So there actually they developed the Oriza model series. And then Oriza 1N was developed by IRA. And then we came to InfoCrop in 2004-5. We started working on. We had a World Bank Center of Excellence on Crop Modeling, where we trained several scientists, maybe about 200 in numbers, for 17 crops actually we took. And then in that process, we developed InfoCrop model. And then actually those crops are very important for South Asian region. And then actually we came to Info Soil also in a way to understand about the NPK optimizations. So that way actually we were diversifying in a way with crops, as well as our group was also expanding. And by now actually we have around more than 200 papers by our group. Not from our side. We preferred that the other scientists who have taken training on modeling should publish these papers. So that way actually I'm happy that InfoCrop is in the working groups, and in India and in Bangladesh also some people are working in InfoCrop, but most of them are working on DSET. I gave them training on DSET, which is slightly more versatile when I compare with, because InfoCrop is not that user friendly in a way to cover the many other options like say sensitivity analysis or those kind of things. InfoCrop is also very good in a way that the crop parameters are very important, and then you can learn about all these 17 crops. So acquired models which we tested were DSET, and then WOFUST, World Food System model is there. It's a simple model. Then DNDC model is there, which is talking about the emissions and the nitrous oxide emissions for agriculture and forest systems, which you can use. It has a great potential. So that way actually this kind of activities are increasing, and IRA happens to be the lead center for modeling. But then actually now I find that many groups in Punjab or in J&K also, like Latif and Kiraj, they are working on modeling. Then Indian Meteorological Department, this FASL program is there, where you are also partner in that. And then KK Singh is coordinating that work from this place in a way to handle a network on forecasting of crop yields. So that way actually this group is doing good work, but I'm interacting with them quite frequently in a way to have some kind of advanced learning on these aspects. So that time actually I remember in 2013 we conducted a training course regarding that mission, where the thief was also there. And then actually I come to InfoCrop in a way. InfoCrop is a dynamic mechanistic crop growth model which integrates daily weather data in terms of rainfall, temperature, solar radiation, wind speed. It also has a component of insect pest. Pest dynamics actually we have to force in. Okay, what is the intensity of insect or pest at a given point of crop growth? So that we have to force. The population dynamics of pest population dynamics is not built in. then actually some groups are already working on that. In Bangladesh, one group actually has at Piri, Bangladesh Research Institute, has started on population dynamics and second test. We have published a paper also in terms of that. And then actually you see the soil properties in terms of moisture retention, release and transmission. And then actually salinity and sodicity and fertility. All these aspects are taken by this crop model, info crop. And then variety specific phenology and then the physiological coefficients and the genetic coefficients are to be built in for the cultivars which you are growing for those crops, and then the agronomic inputs in terms of the fertilizer schedules and irrigations. So that way those inputs are to be given, and then we run the model and we try to assess the yields, growth and yield of crops. We try to plug in with the resource management options. We try to see the effects of variable water supply on crop yield. We also see the effects of climate change and climatic variability on crops and yields, where a lot of papers are there by Jammu and Kashmir group also is there. I find I always say Kashmir, although now it is a bit different, but still you see that I see that some group from JNK, they did good work on modeling. So this is the chain diagram or the line chart of the info crop model, which actually has the weather, and then actually see weather components, and then it also has the water balance components. Okay, how much water is staying in the soil profile, how much is going drained out, and then actually how much is when you give irrigation, how much moisture distribution or redistribution in the soil profile is happening, then how much transpiration is taking place, how much evaporation from the soil is taking place. Then the plant growth component part is there. What is the phenology and what is the physiological processes related, like say how much is the respiration and what is the net primary productivity, what is the root growth, rooting depth, and all that. All those components are dealt in details. Then the nitrogen part is also very important in a way that how much nitrogen, mineral nitrogen is available through fertilization, and then how much nitrate and ammonical nitrogens are available, how much leaching or how much uptakes are taking place. See, all these things are written in a very detailed way. And then we have the source code of infocrop also, where some students and some scientists, they want to work on infocrop or they want to develop their own some model, as well as nowadays I believe in simple crop model growth development, VSM, very simple model development. One page Excel model or FST written, or whatever language you say, and then you try to define the radiation use efficiency, water use efficiency, and then phenology, and then actually through that climatic parameters you try to design a simple model for crops. That's my intention, that at present actually the the summer moonbeam crop model which I developed at Bangladesh, uh, Jatish Biswas, he is the lead of this paper, and he is the coordinator. He was the coordinator of climate change mission program there. About 40 scientists are there, like very dedicated, and I find that I was impressed with Bangladesh group in a way that they were hardworking, as well as their successes were, in a way, if you see the kind of the papers which they have published, at least now they are started coming on IPCC platform. So that way it's really very good satisfaction. I provided training to them on crop modeling, and then simple remote sensing tools in a way to integrate. So those kind of results, soil health index, and then soil fertility indices for Bangladesh. So many aspects we touched. So in climate change, actually, my intention was to understand, to integrate all the system components together. And then extreme climate is also important. So minimum database for simulating crop processes, I already told you, the daily weather and soil parameters. And then actually we have, in India, we have a lot of soil information in terms of soil test values. And already we have made in InfoCrop, you have the district-wise soil characteristics inbuilt into the InfoCrop model. You can see that, and you can use them also. And then we have some weather files in InfoCrop, where actually for many locations, the weather files for different years, all the historic weathers are there. So you can run them in a way to understand. And then actually you can just play with these kind of crops. One result actually I show you that in crop models actually we have level 1 production. Level 1 means protection, genetic by environment interaction. What is the genetic potential of a crop for a yield? And then actually how the climate is interacting, where in level 1 we are not talking of water stress or nutrient stress or insect pest stress. What is the potential of wheat crop? Like say if I say Punjab region, where the production can be to the tune of about 8 to 8.5 tons. I can achieve yield of 8.5 tons or so. But the Punjab average is around 4.4 to 4. It comes between 4 to 4.5 tons per hectare. Because of the variability in the soils within Punjab, I talk of the overall the Punjab average in a way. There may be nutrient stress somewhere, there may be water stress somewhere, there may be insect pest, and so that way the genetic potential level 1 is relatively higher, where we try to find out that. In level 2, it comes the water stress. So with the modeling comes in a way that we try to introduce the water switch, water stress switch, then actually comes the nitrogen stress switch, then comes the insect and pest. So InfoCrop has all the levels. Level 1 is your G by E, level 2 is your water stress, level 3 is nitrogen stress, level 4 is your insect and pest component. So that way actually these stresses are coming. But then in the later stages when I joined Tata Chemicals, then the multi-nutrient deficiencies were important. So in dynamic modeling, that's difficult, because actually if I am talking of the mechanistic growth models, the covering of all these 15 or 16 nutrients together is difficult in a way to develop the model. So that way actually we actually started developing like QEFT's model or Excel based nutrient optimization models we developed at Tata Chemicals, which I can share with you. And then actually you see that we define the dosing or the of the nutrient dosing in a way the balanced dosing doesn't degrade the environment and all that. So that way actually you see this particular slide is showing, you see, this is basically on the basis of met subdivision scale. We run the model InfoCrop in met subdivision scale of wheat growing areas in India. And then actually on the basis of the historic weather data, we try to work out the yield variations. So these are the yield probability distribution of yield over years. Like say if I say 25 to 50 years of weather data, running that, we try to find out the probability of getting the yield in terms of level 1, in terms of water stress and all that. So that way actually we have, so this way shows the capability of the crop models in a way to understand the different crops in, like say, Jammu and in Kashmir environment, how actually the over years how a particular crop is behaving, how the crop is behaving in water stress, how crop is behaving in nutrient stresses and all that. So that way you can build in those kind of components. I wish to mention here that some of the young people should advance, should intercept the advancements like machine learning or neural networks and artificial intelligence in a way to understand that how the how the artificial intelligence can be tuned for micronutrient dosing in a way, as well as for nutrients management, as well as for forecasting of the yields and all that. So that's a new area where you have to pick up. I find that a lot of work, a lot of actually groups working in machine learning, but I find that in agriculture research or components, the kind of the component which are to be addressed are not being touched. So in a way that we need to have clear understanding of the agriculture processes in a way to link with the crop models as well as with the machine learning tools in a way to link up. At present, actually, I am working on these crops for strawberry crop for yield forecasting. We're using the machine learning as well as the crop models. So that's actually the kind of the mission actually we are picking up. And then maybe some of the young generations, because now we are coming in the old category. I am already 65 plus. So, but still actually you see that the mission has to be taken up by the young communities in India. And I find Latif is there, Shiraj is there. So these people have to pick up. They are the guiding force. They are teaching, like say some groups in India are there. So they should pick up and they should also do advancement in some kind of simple model development as well as these things. So this is one slide which shows about the optimum sowing window of a crop. So you see that for wheat growing regions in Eastern UP, Western UP, in Bihar, in Punjab, in Haryana, in Eastern Rajasthan and all that, what is the optimum date of sowing for wheat? So that way it is on the basis of the runs which we have listed. We published these papers in Field Crop also. This paper was published, and then we brought a book also, InfoCrop as well as WT Grows. So you can go through that manual. That's already there on ResearchGate. This manual is there, as well as InfoCrop is available at IRA. So, and then actually you can, Dr. Naresh is at present leading the group, and then we are also, Agarwal is also there in climate change framework, actually on international mission. And then actually these kind of groups are already actually interacting, and then these developments are taking place. But now the need is to switch over to crops like forest trees, tree species. Some of the horticultural crops are very important, and then some of the insect pest component is to be strengthened. And then actually that way actually you see that the you see that the basically the as we actually switch over the or delay the sowing, how much percentage reduction in yield can take place under level 1 or in level 2 in water stress situations and all that. So that way the potentiality of the, now see radiation and temperature interaction. So if temperature rises, the, like say this particular graph is showing, this is a good curve for wheat crop for New Delhi environment. You see when temperature, you see radiation decreases, aerosol events are happening, the unburned carbon or residue burning is also coming into picture in a way, the radiation reduction. That event came in 99 or 2000 when aerosol was very dense, and then solar sunshine hours got reduced to 25% to 30% only. So that way, actually, when UNEP, United Nations Environment Program mission was there, I was also a panel expert. We run the model. We published a book also, and then actually this network was created, radiation and temperature interaction. You see lot of differences you find. Then actually with temperature increase, the productivity goes down, as well as radiation also, temperatures, they are interacting each other. So through models actually we are able to understand that. And then actually you see that actually this sunshine hours got reduced to 30%, but the solar radiation only got reduced to 13%. That means because of the diffuse radiation, the component of radiation was still coming, although the cloudy condition was there, kind of thing. So that way, actually, you see the diffuse radiation and scattered radiation was coming, and then actually we try to evaluate the effect on, in that particular specific event for sugarcane, rice, and wheat, and then we find out that the extent of reduction came to only about 2 to 3% kind of thing in that specific extreme event, or 5%. So that way, actually, these kind of some kind of discussions took place at international platforms, and then a particular atmospheric brown cloud, ABC. You can see a report, ABC, atmospheric brown cloud, where I was also a party. And then I joined Tata Chemicals. Then the other groups came in at IRA. A.K. Singh joined that group when I left Tata Chemicals. So I was, at that time, was leading that group, and then A.K. Singh became the leader. And then actually they worked out on the effect of aerosols. That report is there. I'm also one of the authors in that kind of reports. You can see that ABC, atmospheric brown cloud reports, synthesis report, and the preliminary report was published by UNEP, and that also you can go through in my that particular research gate, as well as on your website also you can see that. So I'm talking of you see that, and response to water availability. Like say, I'm trying to link in several kind of aspects, like say radiation temperature interaction, effect of temperatures, data of sowing, and all that. And then carbon dioxide enrichment, or if carbon dioxide concentration is increasing, how they are going up and down. What is the kind of the carbon dioxide and temperature rise interaction taking place? So that way the water is also important. If adequate water supply is there, you see, for wheat crop, adequate water supply is there, I have to apply more nitrogen. The extent of increase in yield takes place if water is adequately available. If water is moderately available, then the optimized dose of nitrogen for nuclear can be around 90 kg or 100 kg or so. But in limited, when I give only one irrigation to wheat crop at ground root state, the extent of fertilizer dose which I have to keep is around 50 to 60 kg. So in rain-fed systems, you see, the nitrogen level, you see, is not showing any kind of increase. So that way, actually, this kind of environments are there. It may be showing a different response for different locations. It may be showing a response for different environments, and like say in Srinagar environment, how the response is with fertilizers dosing and taking place. And then you can run, these are the model outputs. So in modeling, if you have a good validated crop model, so you can show those kind of optimizations under different levels of water availability and the different management of, in a way you can tune them. So this kind of work is reported in Bangladesh papers also. So you can go through that. I find that there is a very diversified groups. Lot of production environments are there. Like say you have from Pakistan, from India, Nepal, and other countries. Fiji you were mentioning, and some other countries. So I could not know the detail, although Shiraj was mentioning about that. But then actually you see that. Then actually we did the geospatial mapping, or the potential yield of wheat. That what is the potential yields of wheat in different growing regions of India, and what is the potential yield of rice in those. So for crops, actually we have made in Bangladesh recent papers, we have published those things. In total Bangladesh growing environment, we have published these papers for rice, and then for wheat also. The vulnerability regions for climate change and all that, you see. So that way, actually, these are the modeling results in a way that if you have a good validation model, this particular result is level 1. That means G by E interaction. But then actually you can do the mapping for level 2, water limited environments, nutrient limited environments, and all that. So then actually some shifting of the productivity centers. If climate change takes place, temperature rises to the tune of 2 degrees centigrade, and then actually you see that carbon dioxide becomes 425 ppm or 550 ppm, the productivity centers will shift northward. So that means northward productivity is shifting. That means the productivity is declining and the productivity centers are emerging. So we need to identify the newer emerging productivity centers for crops. So that way, actually, that's very, very important. Where actually uh, in Kashmir or Jammu, regions, you can do the through you can define the kind of the agroecologies delineation of those particular Jammu and Kashmir, and then you can work out, impose the model results on climate change, and then you can work out how the different regions, growing regions in Kashmir or how growing regions in Jammu will look like, and where the productivity centers will be now more, which productivity centers will be more vulnerable, kind of things. So that's very, very important. So then actually, you see, I quote you one example of, you see, you can use, like say, image processing is a difficult venture, but I find that Modi's satellite imagery is there. In ASCII format, you find out the data in terms of net primary productivity, leaf area index estimates and all that. Somewhere, sometimes you find on weekly basis, sometimes you find on fortnightly basis, the kind of the results for different growing regions through Modi's data, and then you can find out the productivity over years in a particular test region, and you can find out how the productivity is looking like in terms of greenness and all that, and then you can link up those kind of things with the kind of the progress development taking place in those regions, and then you can work out, like say, I did a lot of work actually. This time we did some Bangladesh as well as in India also, in one of the yield forecasting center in Noida. Dr. Singh is the director actually of that center. And then actually their SkyMat actually is they are basically taking the signatures and then they are trying to work out those things. So Modi satellite ASCII data, spatial and temporal for vegetation, characterization, land use, in terms of NPP, and then actually grass primary productivity, leaf area index, intercepted power, NDVI, evapotranspiration, NASA data from weather. You can find out the weather for all the locations through NASA platform, daily weather data kind of things, and you find out all these parameters there. Agronomic and inputs management, you link up and then you can run the models also. This exercise was done by us when Space Application Center was linking up with the kind of the crop models. That time WT Grows was there, and Dr. Dadwal was actually the leader from Space Application Center, and I was leading the IRA group. And then actually we developed the WT Grows model in a way to link. And Dr. VK Sahgal now who is professor in agriculture from Space IRA. So he actually did his PhD that time, and then he did a good work. He's still continuing good work on agrometeorology and remote sensing. And then actually the satellite actually linkages, signatures linkages with the crop growth model for yield estimates. So that way actually this particular event was exercised, and then subsequently it took the shape of Fasal. Fasal came out of that forecasting by linking with the agromet components as well as with the satellite signatures and then with socioeconomic compartments. That way actually linkages were there, you see. So this basically, you see, we did with the help of the ground truths, we collected leaf area, and then we matched up with the NDVI, and then we developed a relation of NDVI and LAI for wheat in growing regions in Punjab and Haryana and Delhi and then Madhya Pradesh. There actually, this is example for Delhi we am showing, but then actually we did the ground truth sampling, and then we developed relation of NDVI to link up the satellite signature for LAI, and then we forced in the value of satellite pass with the crop models to run the model in a way to forecast the yield. So that way the yield mapping platforms were done and kind of thing. And then actually forecasting yield, we started on met subdivision scale. We were running the model and we were trying to forecast the yield by taking the weather data on daily scales and then weekly scales. And then we were running the model in a way to the yield forecast during that time around 2000 or 2001 we were doing that exercise, and then we We forecasted the yield early, you see, in modeling outputs, although the Ministry of Agriculture estimates were updating later on. So it showed the potential of the crop models in a way that how we can design. So this is an advanced platform where IMD, KK Singh and group is now working on that along with the SAC group. And then SAGAL is also there at agriculture physics. So they are looking into these kind of aspects. And we are also trying to see that how this thing can be done. And so I'm also associated with the Bangladesh mission as well as this forecasting I'm attempting in North American environment also. So climate change impacts, which actually we need to address, is insect as pest component is very weak. Population dynamics of insect and pest to be developed. Delineation of insect pest is very, very important. Economic threshold level of insect and pest in different growing regions, in different regions of the country, linking with the climate and the other biotic and abiotic layers. That's very, very important. So this actually you have to, then climate change and fishery, although actually good work is happening in India, but still actually we need to address mapping of fish population density under normal, extreme and changed climate, model development for life cycle assessment under climate change and climatic variability, fish quality assessment under climate change and degraded environments. Degraded environments is very important. Vulnerability and adaptation related studies through development of suitable indicators. That's very important. At present, we are stressing more on these aspects. And then climate change and livestock is very, very poorly dealt with, although NDRA, IVRA have covered these things from India. But then actually in Bangladesh, I remember there's a institute near Dhaka. They are also now started working on this. I had some meetings with them. Methodology development for GHG emissions for ruminants under diverse growing environments, life cycle and productivity assessment, vulnerability and assessment. Those are the kind of the things which needs to be addressed. Socioeconomic components are relatively weaker, although Terry is working on these aspects and linking the socioeconomic scenarios and climate change scenarios with the climate change scenarios in a way to work out the socioeconomic aspects on agriculture impacts as well as the kind of the management options which can address. And then actually I remember that in Indo-UK program on climate change, I was leading the agriculture aspect where Terry was given the theme of socioeconomic. But when I find the reports that time, but now there are some developments. So we started that time when the program was going on. So I still remember that. And this component is strengthening also now. So greenhouse gases emission, some work in Bangladesh is already going on and good work is going on. We have now actually greenhouse gases emission through cool form tool. Actually, we published some papers relating to methane and nitrous oxide emission. Zonation maps for various Bangladesh growing environments. Already we have published this paper. And I remember that Shiraj actually conducted a seminar that time about 2 or 3 years back, and they published a book, Springer Nature, Nature Public, what is that? Springer Nature, I think. And then actually they brought a book also. Shiraj has published a good book, and Latif book is also has come. So we have to refer those things, and already Bangladesh growing environment one paper is listed there. I remember that. And then InfoCrop and DNDC models to be used for these things. And then we have to develop some simple crop growth models for GHG emissions. So that's the mission where we have to further go. Climate change impacts on major cropping systems, rice wheat systems, rice systems, and the rice maize systems or maize wheat systems like that. Actually, these kind of things, very, very good actually potential. DSET is that way potential tool for for running the models for this kind of things. Multi-location long-term trials are already in several countries, and then we are trying to do that also. So others activities, you see that we find that the development of the simple models, weather and horticultural crop interaction is very important. Work related to agroforestry and climate change. Work related to forest ecosystem and climate change. This already we started at FRI, and some group is already 3PG and other models are there in Canadian systems. They are already having good models on forest. And our model has also come on Pinus. Dr. Manoj Kumar is now leading the group. He did his PhD. Latif must be remembering he attended this training course in 2013. He's a senior scientist at Forest Research Institute. So he's doing a good work, and then maybe he was my student for his PhD program, but he is now leading and he's going ahead and he's really doing a classical work. And integration of biophysical and socio-economic aspect with the crop models for realistic estimate is very, very important. Characterize land use type and assess land cover change. Now the one component is integrated assessment modeling, where we have to intra in agriculture or intersectoral, like say energy sector is there, the infrastructure development, the kind of the forestry sector is there, agriculture sector is there, water is there, mission is there. So all those things we have to develop some kind of models which can have the integrated assessment of climate change. Now sector specific studies like say vulnerability assessment of agriculture. So that's important. Which areas will become more vulnerable in relation to climate change? In relation to regions which are more extreme climatic events are coming, which are more vulnerable as well as the extreme climate occurrences probability is higher. We need to address, we need to also know that how we can sustain the crop production in that. What are the kind of the agronomic management options and those things which are there. And then I show you one simple forest growth model in Excel we developed. So Dr. Latif, how much time is with me?
Sir, you are having 10 more minutes, sir.
Eh?
10 minutes or more.
Okay. So simple forest growth model is actually, you see that if I have a good compilation data set in terms of physiological processes, in terms of soil processes, in terms of soil mineral, in terms of the litter fall, in terms of the mineral nutrition of the tree species and all that, then actually I took around 3 months time to assemble all those database. I had discussions with the Forest Research Institute group, and then that was part of PhD thesis of Manoj Kumar, and then this part came out from that, and a lot of good work has come. And you can see that how the vulnerability assessment was done, how the the forestry ecological centers were, pioneers were worked out in India and all that. That was basically done for Western Himalayas, where actually this was done. So then actually this particular simple module development took place, gross primary productivity. And then actually we worked out the net primary productivity, and then actually woody productivity, different plant parts and all that, standing biomass, litter fall and all that. So this way actually the Pinus Roxburghium was developed. And this became a newer study. We published the phenology part in ecological modeling about last year, 2019 it came. This paper was published, and now a series of papers will come. Already actually this is in the writing stage. So, and that way actually we effectively use the databases, and then the interaction with the researchers in that group, and then actually we ask the help of the Moody's satellite imagery for NPP assessment and all that. But it's very easy. So you can take up those kind of things. Key activities of forestry is basically.
You carry on, sir, please.
So development of forest ecosystems model, simple model. I think that way That way our friend Latif can concentrate and can introduce some kind of important tree species for this region. That will be really nice. And some kind of horticulture crop. So we are there always to help you, whether I'm in Canada. So although now I'm PR in Canada, going to be citizen within a year. So but then actually I'm always with you till I'm active, because I'm an old man. You have to take the mission. So DSS for developing these layers, climate change, climatic variability, all information dissemination systems, understanding the interaction of forest agriculture is very, very important. The this is very the near forest, the villages, villagers, what are their problems, what are their livelihood security and all that. Those kind of models, simple models to be developed, capacity building on modeling of forest ecosystem. That's a mission actually which is with us. And then Forest Research Institute and ICFRE is also work at. So I'm also directly associated with the group. And then actually I just hurriedly go through the soil databases in terms of primary moisture retention release, soil fertility evaluation, organic carbon budgeting. This particular curve shows about 10 years back we published this paper in organic contents status of the Indian soils and all that. And then actually see, we made some soil quality assessment, online linkage with DSS for soil quality fertilizer recommendation. This Pathak now is actually this institute director. So he is an active worker on soil systems. So he already actually developed this thing. So InfoSoil, and then InfoSoil we were there to run the QEFS model, and then in Tata Chemicals we started developing, including other nutrients also. In Excel format I developed that model. Development of soil health rating index is very important. So already 2 papers have come in ResearchGate. They are available from Bangladesh systems. We have developed that. The criteria of developing the soil health index, I think Latif should go through that, and then this work should be initiated by your group also. And then what are the important attributes of that, and then how the soil health index in terms of water, in terms of fertilizer management, in terms of the other soil physical aspects, soil physical health, soil chemical health, soil biological health, all these components are to be integrated. We debated in that paper, you see. And then a good model, in Excel based model I developed, and then actually through ITRICI, we did the mapping for the entire Bangladesh. In soil health, basically soil biological health index is important. Development of soil managers for problem soil handling is very important. Modeling of tillage-induced soil properties. Development of simple model for climate change and climatic variability. Some missions are to be done. Soil health service, nutrient management, water management, tillage needs, zero tillage, minimum tillage, residue management, all these components are coming. Although results are there, a lot of work has been done, but models are not there. Some simple models need to be developed. And then insect and pest extent and control options on the basis of irrigation scheduling and all that. This actually, I just quote you one thing, managers. In Excel-based managers for acid sulfate soils, manager for soil constraint like say physical problem constraints, manager for soil constraints like say saline sodic soils, acidic soils, for biological health of the soil. Soil health managers carbon calculator for carbon sequestration, green manure calculator, how much green manures we place and all that, water use efficiency calculator, lime benefit and cost calculator, nutrient management calculator in terms of pH, EC, and that's very important. pH and nutrient management very important. All those things actually in Tata Chemicals we were making all these Excel based decision tools, in a way control traffic calculator, and then that way actually a lot of material is available and a lot of thoughts are available where actually these works can be done. Then optimizing fertilizer use is basically QEFS model which we modified. in a way to crop model from potential yield and current yield. With the help of them, find the target yield, and then we did the fertilizer recommendations. This QEFT model was further expanded for other micronutrients also in Tata Chemicals, where we designed customized fertilizer. So this is the customized fertilizer actually which we developed. What is the nutrient requirement of a crop? How much is the soil nutrients availability? And then how much is the nutrient needs in a way to define the yield or target. And then this particular model was developed by us at Tata Chemicals. And then using STCR and QEFT's model, and then our scientific wisdom, and then Excel-based models were developed for different crops and environments. So the customized fertilizer, which we developed on the basis of that, a single particle, fertilizer particle providing all the nutrient needs. So that particle is able to provide boron, this kind of uh, particle fertilizer products were manufactured by Tata Chemicals from our centers, and then actually we showed that they are actually economically feasible, as well as the profitable cost benefit is also increasing. So farmers got the benefits of that. You can go through these reports. So our mission is on online agro advisory, pre-sown agro advisory, post-harvest advisories. The AgroMet platform is very, very important for that. FASL is an important mission where IMD is taking the lead, and SAC is also there. And then the center, special center, where you see already the SS Ray is actually basically, Roy is basically taking care from remote sensing. So that way, and VK Sagal is there, KK Singhs are there. So a lot of leaders are identified out of that. So, and then actually basically integrating the biophysical and socioeconomic aspect with the model, and then linking the weather, the alarms and all that. So those kind of things are important. So basically we need to devise a kind of a crop growth monitoring system, which we have in European system. So this kind of database is to be developed. This kind of system is to be developed by India. And then actually, you see, I will just take 2 or 3 minutes more, and then I will wrap up. Although Latif, as a course director, he asked me to theme director, he asked me to address on extreme climatic events. But then I thought that I should cover not only climate change, should cover the other kind of forces in terms of, because when we are addressing climate change, like say if I talk of Canadian system, if temperature rises by 1 degree centigrade or 2 degrees centigrade, sometime the productivity center will be giving more production and all that. So some crops will be beneficiary. So if I talk of say Amritsar environment, 1 degree centigrade temperature rise is going to benefit wheat crop. But if it comes to 2 degrees centigrade, then actually the reduction in yield also coming. So it's basically understand about the radiation, temperature, and carbon dioxide interaction in different growing environments in a way to understand that how actually the productivity and the productivity center will look like. The kind of the themes, that the kind of the knowledge gaps are insect and pest, socioeconomic components, the horticultural crops, the forest ecosystems. So these kind of things. And then the need is simple crop growth model development. I can anytime interact with you in terms of develop simple models. And then actually you can just guide some student or put some students in that direction in order to develop those kind of things. But then I take 1 or 2 minutes more in a way to address extreme climate is very, very important. Climate change, when I compare climate change and extreme climatic events, climate change is a slow process. Already some kind of adaptation learnings are taking place. And then the land use and land cover change dynamics is also happening very fastly. It's not only climate change, the climate, the land use, land cover change are also playing an important role. What is the kind of the population pressure? What is the kind of the industrial pressure and all that? So that's important. But to me, actually, linkages of the into sectors and linkages of the land use and land cover change is also important. But then the other aspect which I talk of is the extreme climatic event. To climate change, it looks to me extreme climate change is very, very important, because the probability of occurrence of the extreme climatic events have increased over the last 3 decades. I'm finding all of a sudden the temperature rises, all of a sudden the radiation, because of the aerosol, because of the industrial pressure, because of the residue burning, the kind of the radiation is reduced and all that. Aerosols are coming and all that. So those events are now quite frequent kind of thing, that temperature rising or temperature cooling is taking place, radiation changes are taking place. So that way, actually, you see that we need to understand that how to sustain the agriculture production in those kind of things. We need to have a learning platform, or we need to have a platform ready for that in a way to address those things. That's actually the real the message. Otherwise, extreme climate events and climate change are basically, climate change is a bigger platform, bigger set, out of which the extreme climates are a subset, but they are almost related to tune the extreme climatic events. But then there are some tools like our climate axis there, so you can characterize the climatic, because you can understand about the different years, the historic years, the how the climates are looking like in Srinagar environment, in Jammu and all that. So they are actually how, what are the kind of the extreme events, what is the probability ki temperature increase by 1 degree, or the drought appearing for what kind of frequency. So that way, actually, one need to understand that what is the effect of the extreme events on rice productivity, on wheat productivity, on some crops, maize productivity in your regions and all that. So that's an important aspect which actually I was concentrating more in Bangladesh during about in 2018. I was very keen, and we were trying to do the extreme event that our Climadex, the rice crop. And then actually we published a paper also. Good paper has come out. And then actually the you see that the Maniru Jaman actually is a good worker. He's a water management scientist, but tremendous worker actually from Bangladesh. He works at Bangladesh Research Institute, Rice Research Institute, and then he did this Arclimedex running. And then actually there's good people are there in Bangladesh. You can always interact with them. You can work with them also. Jatish is there. Jatish Biswas. He's retired, but he's very active. Munir Jaman actually is very, very active in Bangladesh Rice Institute. In Bari also, Bangladesh Agriculture Research Institute, there are some potential workers, they are working on horticultural crops also. My interest was to work with them also on some horticultural crops, which maybe I think now actually to go there many times, but now I'm in Canada, so my going has reduced, but I will love to visit your place. But then extreme climates are important. Modeling runs, understand, and trying to develop models like ArcClimeDex for people like you also is important in a way to characterize the extremes. So thank you very much.
Thank you very much, sir. Thank you, sir. Thanks a lot for your nice and informative lecture. I hope the participants had really enjoyed your lecture from Canada. So you take so much of pains for us, and we are very happy that you accepted our invitation. And I'm rather very happy that you are with us right now. So, sir, we are having some questions in our chat box. So
Yes.
I'll ask you one by one. The first question is from Nimra Areen from Pakistan. As you have defined lots of input variable for crop modeling, how much minimum crop variable for crop modeling for those regions where we do not have much crop related data due to less advancement in technology?
Yes. So that's very, very important, Latif. But our Ashaq Hussain is there, na? It's
Yes.
I'm finding his actually face, and then you are from Pakistan.
No, sir.
No, sir.
He
Sir,
is our senior colleague, sir. He is our professor in agronomy.
Oh, sorry.
yeah, sir. Actually, I was fond of listening alumni of IR, right? I completed my PhD in 2012, and agricultural physics was one of my minor subjects.
Oh, very good.
But by then you had already left that division of agricultural physics. I was
Yes,
really fond of listening to you, sir, and this was a great opportunity. I
nice,
worked
nice.
under RMC.
Yes, very good. So,
Anyway, sir, my question is related to this modeling. A lot of models we use, for example, InfoCrop and Boost and many other models. But sir, if a student or a researcher commits error in weather data or crop data related, if in any of these data we see some error is there already, the work has not been done honestly, then how far it will affect the results our decision making process? That's my
very, very important question, and very important. Your professor, and then you see. So your comment on. I also agree with you. In InfoCrop, when I see the file data files, some kind of misses, some kind of values are to actually we need to modify those. But then actually you see that already actually what you're saying is that the kind of the data base requirements kind of thing what you're saying, actually we need to have a field capacity, wilting point, saturated content, and then total available nitrogen, these kind of values which are there. And then actually what I used to do was a lot of is already available. You are able to hear me?
yeah, I'm listening to.
So in that way, actually is that if I see the literature search, lot of things I'm able to find out in some of the database part of InfoCrop or some other models. Even Day-9 also I find some anomalies on kind of data. Then actually we need to see that third eye opening, which are kind of thing happens, but in a way that the model is there with us, and good kind of model is there, good kind of data is there with us. So let's identify the mistakes, try to rectify them also, and then let's write it down. So I'm happy that agriculture physics student and professor from your place is also really great.
Sir, he is gold
So
medalist, sir. He is our respected scientist, very renowned agronomist.
that's very good.
Always helps
Ashsan.
all of us.
Oh,
Yes,
oh,
yes, sir.
nice. So you did
Thank
with
you. Thank you.
Sahu.
Yeah,
Sahu
I'm
is a
sorry.
good worker. He was
Yeah, yeah,
Vashisht Shakti,
yeah, yeah,
and
yeah, sir.
then actually you see VK Sagal,
Yeah,
and
yeah, yeah.
then
All of them
all these
motivated.
people
TK Das in
they are doing.
agronomy professor at that time. I went to higher PhD.
अच्छा.
I use
So
spectroradiometer
what
evaluation
you are
for environment.
saying is I'm arriving at, because you are more expert. I'm just a user. Somehow I find nowadays now if I download that some particular grid make for a latitude longitude, I values of P and all that. Although there may be some definite, I'm able to work out the for that particular region. If I traverse about 10 years or 15 years, the values of NP changes are taking place and all. That is really tremendous. So I don't go for image process. I work asking it, and then I try to link the crop models, and then for my result. So that the forestry and all that is very important. So really, Ashak, I think I'm happy. We'll always be in touch, and we'll be
Thank you.
interacting with each other. Now a scope of simple models can be developed very simple. It's not a rocket science, very simple science, and you can do it. You can do more than me, and definitely I think it's a era of that. Some new crops also. So that's the kind of direction which you have to take.
Thank you very much, sir. So nice.
Sir, we have one more
Thank
question
you.
from Sir Dr. Manish Deshmukh. Sir, you can please elaborate how socio-economic layers can be integrated with crop models.
So, what is the name?
Sir Manish Deshmukh, Dr. Manish Deshmukh.
Manish
Yes.
Deshmukh. So his picture I am not able to see.
Sir,
Na?
it's very hard to find his picture because we're having more than 200 participants.
Achha. Achha. Oh, 200 participants. Oh my God.
Yeah,
Achha, that's
I'm
very
here,
good.
sir. Can you hear me?
Yeah, yeah, sir. Manish Deshmukh is
Oh,
very good.
Yeah, I'm
Manish, it's
working.
really very good. Eh?
I'm
Nice,
working
nice.
as agronomist, agriculture university, agronomy department.
Oh yes, very good. Nice. So your question is very, very relevant, and that's very the most weakest part of climate change research. You see that when I talk of two things. When I talk of the climate change, if it has happened, one thing is vulnerability assessment means which are the vulnerable regions of climate change. Like say if climate change has happened, which crops are going to be vulnerable? What are the mitigation options? Mitigation options means we have to control the emissions and all that. How the agronomic management can be reduce the emissions, and then adaptation. So socioeconomic component, when I come to adapting component, I suggest the adaptation means climate change has happened. So what kind of and resource management, input management option should take place in a way to sustain the agriculture production. Whether options which you are providing are socially acceptable, cost benefit wise acceptable, that is the question. So that means the socioeconomic component is interacting at the time when the has taken strategies are going to be defined. So in adaptation strategies, socioeconomically acceptable or cost benefit wise acceptable to the farmers kind of thing. So whether they make sense of very, very important. That is one component.
Yeah.
The second component is what you are saying. The second component, social scenarios, economic aspect, scenarios of, like say if I am generating a future climate change scenario. So I am generating a socio-economic scenario in terms of land holding.
Yeah.
What will be the land holding? What will be the resource availability? What will be the water, surface water and groundwater availability and all that? All those components will be there. What will be the kind of the other intersectoral pressures which will be happening? Very, very important. Future scenarios in climate change scenarios for running the model. So socioeconomic scenarios are a weak component in a way. How much will be the mechanization will be looking like? What will be the acreage defined in that? If it is a intensive agriculture, kind of the scenarios are going to behave very complex. If it is an extensive system where the holding is very high in USA or Canadian system where their holding is around 500 acres or 500 hectares of land and is holding that. So the kind of the management are difficult. But if the holding is less than 1 acre, so socioeconomic scenario, like say the Terry has done some, then actually in your case, when you are raising the issue, if once the climate change has happened, the adaptation options are management options are defined in a way to have the socioeconomic or benefit wise friendly options acceptable to the farmers. Then actually it comes in terms of the crop choices, in terms of those kind of things. Then the second scenario is developing the socioeconomic scenarios, future scenarios. But then to link with but that future scenario has to also integrate the agriculture, population dynamics, the industrial pressures, the other sectoral pressures and all that. So maybe some kind of intersectoral interaction also. Some person like you, Manish, you can think on that sectoral interaction, future scenarios, or the present status of that. So that way, actually, this component is relatively very weak. And then actually we see we are in a hurry to publish papers with run the model and some kind of results. So sometimes actually they are debatable, they are question marked also. So that way actually as a modeler, I understand the sensitivity, but then you have to really do that.
Sir, one last question, sir, from Preeti Kumar. I read in many research papers that effective temperature is being observed on insect pest through process-based modeling. How it is different from our other simulation models?
So very important question. You see that this question is really a missing link for all of us. This is a missing knowledge gap. This is a knowledge gap, you see. One thing in InfoCrop we tried. In InfoCrop we tried that we force in uh, the extent of infestation through insect and pest at a given stage of the crop. I am running the model. I put the extent of damage or extent of insect pest in the model at that time, like say at crown root stage or tilling stage, this particular insect or pest has come. So this is the intensity of the insect pest. So value, and I run the value with control options like say insecticide, pesticide spray and all that. I run the model, get the results. So that way InfoCrop is capable of doing that. But insect pest component is not that important. It's very complex. One is pest population dynamics. How much, one thing is actually somebody like the group, this is name you, the question asked by
So, wait a
the
second.
the lady who has asked the question,
Sir, Preeti Kumari, sir.
Preeti Kumari. So that's important. If I can do the insect pest zonation maps, if I put the zonation for a target region, particular target region is there with me. I'm doing the zonation analysis. What is the ETL level, economic threshold level of insect pests appearing in that zone over years, last 20 years or 15 years or 25 years, how the changes are building up. What are the newer insect pests emerging out of that? What are the insect and pests which have disappeared? And what are the reasons of that? So it's not only modeling. It's basically the kind of the expert judgment or the kind of the direction which you are thinking. So that's more important. Okay, what are the kind of the new insect pests which have come or coming? And then actually the donation maps of those things. And then actually you see, so in that way actually you see, uh, in that process, we have to do the insect pest donations over years. The short term or the newer emerging insect and pest, what are the consequences of that? The modeling component is there, but then actually our model is not that strength in over the globe also. All the models are not taking care of the pest population dynamics model. Okay, how the microbial population is developing, how actually the insect pests are developing, all those things are becoming very important. So to me, the answer is to understand the yield loss assessment, not through modeling, but through their technical judgments and through expert judgment or thumb rules, as well as some kind of technical coefficient developers. You have to develop some technical coefficients for yield loss assessment, quantification and all that. And then actually along with that, you have to link up crop models like InfoCrop kind of thing. And you have to modify it then in that case. In that case, you have to modify it.
Thank you very much, sir. Thank you for the nice presentation and question answer session. Now, sir, we will have one group photograph. So participants are requested to open their cameras.
Am I audible, sir?
Could you please stop your screen sharing, sir?
Am I audible, sir? Dr. Latif, sir?
Yes.
Sir, I haven't found my answer actually. I have one question.
You please ask sir in a live mode, please. Sir,
Yes,
she's a
yes.
participant from Pakistan, sir.
Actually, you have defined lot of input variables in the model. If we have the lake of data variables, input variables, then how much, at least how much variables we need to crop modeling for crop modeling?
Very good question. And I appreciate your question. And but then actually, when I say the mission of very simple model development, so in that case, actually, I already should have maximum temperature, minimum temperature, and then rainfall. If these three data are available with me, some of the secondary variables can be generated kind of thing. To me, if soil texture is known to me, sand, silt and clay, out of that with pedo transfer function, I can generate the moisture retention, release and transmission. So that way, actually, these kind of databases, we have to think in a very positive way. We have to, because agriculture is a living system response, very complex system, like say human body is there. Understanding of the system is very complex.
Yes, sir.
And model development that way is very tedious. So that way, actually, what you are talking of the databases, if I talk of the real databases requirement, maybe around 100 inputs. But then actually we have to reduce it to some genetic coefficient, physiological coefficient, and phenological coefficient. These three components are important for a particular crop. And then soil texture, and then your organic carbon content, and pH and EC, they are important. And then actually maximum temperature, minimum temperature, and some of the information like. So that way I'm a believer of simple model developer. So I believe in simple inputs also. So let us not get moved with that. If we have to want to have, you see, let's not carried away ki data is lacking or like that. Let's appreciate whatever data is there. India is a complex agroecological country, regions. So that way those kind of deficiencies will be there. You will always debate. But the kind of the direction we have to define and the kind of the way we have to define those things, that's the kind of the thing which I feel.
Thank you, sir. Sir, I
Okay.
have one more question. A simple question is that I am from mathematics side. So how can I am doing my MPhil in applied mathematics. My topic is related to weather, climate, and drought. So as I have found a lot of knowledge from this workshop, thanks to Dr. Latif actually for this opportunity. How can I help to the rural areas community as a mathematician to decrease the to increase the crop here? Actually, they are using lots of fertilizers and something which have a more demand of money. Like, so how can I help them particularly?
I think I have the answer for you, because actually I'm also a physics man, so I'm a mathematician. So that's why I could develop these models. So you can associate, join with them in a way to develop a very simple model. But then actually the other theme which comes to my mind is you start learning, you start entering into the field of machine learning and artificial intelligence and neural networks. I find in North
Yes,
America,
sir.
most of the eminent workers I find in University of Waterloo, most of the eminent workers are engineers, mathematicians only. They're not from agriculture background, but they are trying to link up the agriculture databases with the way to understand. My son is now doing PhD. He's a computer man, but he's working on cancer diagnostic. So his PhD is on cancer diagnostic. So agriculture
Sir,
is a
we are
very
mathematician. We can go in every field.
that's why I'm a physicist, so I can go in any field. So you can
Yes, sir.
also go there. So you start developing into machine learning and AI.
Thank you, sir. Thank you so much.
Okay.
Sir,
One
one
Okay.
question
question.
from my side.
No, sir, please, sir, we are having another session at 7:30, so we will assemble for group photograph. I request all the participants to open their cameras.
So all these things are possible. Group photograph like that.
Yes, sir, we are having a problem in Zoom.
Oh my God.
You please, sir,
That's
stop your
really.
screen sharing. आप अपना screen sharing sir stop कीजिए, तो then we will start this group photograph.
स्क्रीन शेयरिंग है इसमें, यहाँ कहीं क्या ना?
Well,
हमारा तो शेयर हो रहा है, हमारा तो शेयर हो रहा है ना. हाँ.
Wes, are you there?
Yes, sir.
Please start this screen.
Sir wants to share screen again, sir.
No, no.
No. You start taking photograph.
It's there, taken or to be taken?
No, sir, चल रहा है sir, हो गया, हो रहा है start. Okay, sir, done. Thank you very much, sir, for your valuable time. You spent almost 2 hours with us. So
Oh my God, I'm
now,
sorry. I'm sorry I took a lot of your time. Eh?
thank you very much, sir. Thank you, sir. We will disturb you
But
again and again because we are start to make models for apple, zira, and saffron crops. They all are niche crops in our Kashmir Valley. So thank you very much, sir. Thank you.
oh, it's really nice. Very good. Eh?
Thank you, sir. We'll
It's
keep
really
in touch, sir.
nice.
Thank you. Thank you.
Okay. Okay.
Thank you, sir.
Bye.
Bye-bye. Bye-bye. Bye-bye.
Bye. Bye.
Bye, sir.
Okay, sir. Shall I end the meet now?
Yes, sir. Yes, sir. Please.
Okay,
Yes.
sir. Thanks.
Okay, bye,
Thanks
sir.
all.
Thanks. Thanks a lot. Thanks
Thank
a lot, all of you. I took a lot of your time. I'm sorry.
No,
But
sir. No,
then,
sir.
Sir,
It is
our
it's
pleasure, sir.
our pleasure, sir. It's our pleasure. Thank you.
okay.
It
Thanks
will
a lot.
have one more lecture
Thanks
at
a lot.
7:30, sir. 7:30 is one
Okay.
more lecture scheduled from Dr. Reddy from USA. So that
Okay,
will be
Shirin. Thank you very much.
Thank you, sir. Thank you.
Okay.
Bye-bye.
Okay, Latif.
Thank
Latif,
you.
thanks.
Sir, we'll keep in touch, sir, through WhatsApp.
Yes, yes. I'm leaving now. Eh?
Thank you,
Okay.
sir. Bye. Bye.
Bye.
Thank you.
Bye. Bye.